Find the volume of the solid formed by revolving the region bounded by the curves y equals the square root of x equals 1, and x equals 4 around the x-axis. Leave your answer in terms of pi. So y equals the square root of x is going to look like this. What I'm going to do is I'm going to take this part to this part, and I'm going to take that little circular looking chunk and I'm going to spin that around the x-axis. And what's going to happen is I'm going to end up with this weird bowl-like figure that's going to be a solid. But that looks just awful. But what we do get is this solid bowl-looking thing. So the method that we are going to use to do this is called the disk method. The disk method is found by taking the integral from your lower limit to your upper limit, so in this case from 1 to 4, and we're going to take the integral of pi times f of x, which is going to be the original equation that you're using, squared. And if you're looking at that and saying, wait a minute, that is kind of like pi r squared, isn't it? It is, because essentially what we're doing is we're cutting this part into infinite amount of circles and then stacking them on top of each other to find the volume. That's why this is called the disk method. All right, so setting this guy up means why don't we rip out the pi. My lower limit is 1, my upper limit is 4, and I'm going to square the square root of x. Oh, happy day. That's going to make life so easy because it's just going to be x dx. Okay, so the integral of x is going to be 1/2 x squared. My limits are still 1 and 4. That pi is still living outside. Now I'm going to plug in 4 and 1. So pi times 1/2 4 squared, a fun game, minus pi times 1/2 1 squared. You become, let's wave our hands a little bit, 4 squared is 16, half of that is 8, so pi times 8, minus 1 squared is 1, half of that is still 1, so pi times 1/2. Not 1, but 1/2. That's 8 pi minus half a pi, which is going to be 16 over 2, 15 halves pi, or 15 pi over 2, which is B.